Alright, in this tutorial we're going to see the conversion from decimal to binary and vice versa. At first, to go back to a former review, so let's check. Here for instance, as you see, is a binary number, and in order to convert it from binary, or in order to check its decimal value, to evaluate its decimal value, we simply add up all the places where all the decimal weights above the ones all the way to the right. You have a 1, okay, in this position all the way to the right, which is the edge, it is the weight 0, and it has a value of 1, which is 2 to the power 0, right? Okay, so on the left you have 1, so we need to add up the weight of this value, which is 2 to the power 1 or 2. Here, where you have 0, you don't need to evaluate it because it is 0. But meanwhile, on the fifth position from the right to the left, and by the way, always to the left you have the highest weights, and to the right the lowest weights. So to the left you have, on the fifth position, you have a 1 which has a weight of 2 to the power 4 or 16. So the decimal value here is 16. And you have another 1 all the way to the left, right before the last position, okay? And this has a weight of 2 to the power 6 or 64. So you add up 64, 16, 2 and 1. 64 plus 16 plus 2 plus 1, you get 83. 83 is the decimal value of this binary number. So let's say you have the decimal number, okay, and you need to get the binary value of this decimal number. So let's say you have a number 110. So is 110 greater than 128? No. In other words, we cannot subtract 128 out of 110. So we need to get to the next position, to the next number right below 128, which is 64. Okay, so 64 is less than 110. In other words, we can do 110 minus 64. Alright, so 110, again, it is not greater than or equal to 128, so we place 0 below 128. 110 is greater than or equal to 64, correct? So we can subtract 64 out of 110, you get 46, and you need to place 1 underneath 64. 46 is greater than 32, right? It is correct. So we can do 46 minus 32, and of course under 32 I need to place a 1. I need to flip the bit, which is by default 0 if you will, to 1. Alright, so 46 minus 32, you get 14. We flipped the bit under the weight, which is 32. Then as for 14, number 14 is less than 16, so here you leave it at 0. We cannot subtract them. Alright, then 14 is greater than or equal to 8, so we can take 8 out of 14. So we do 14 minus 8, and of course I need to place 1 over here, right? 14 minus 8, you get 6. 6 is also greater than the number below it, which is below 8, which is 4. So we can do 6 minus 4, right? 6 minus 4 equal to, of course I need to flip the number here, the bit, to 1. Then 2 is greater than or equal to 2. We can do 2 minus 2 actually. So we flip this number here to 1, and you get 0. Of course 0 is not less than 1, right? So we leave the 1 at 0. Alright, so let's practice binary conversion. We start with converting from decimal to binary, then from binary to decimal, which would be much easier. But at first we will prompt the user to give us a number from 0 to 255. So I'm gonna start with echo, enter a number between 0 and 255. Now of course we're not accounting for the cases where he might enter something outside of that range. It won't be our responsibility in this example. So read none. Then I'll need to store this value inside an input variable, because this number over here will be decremented as we go along. You'll see what I'm trying to talk about. So I will declare an input equals 0, and here input will store the original value of num. Now, of course, at first I need to declare an array of 8 values. Actually, it won't be by declaration 8 values, but as we fetch in it, it will grow up to 8 values, because this is all the bits needed to code numbers from 0 to a maximum of 255, which counts to 256 values. Let's declare an array. So declare dash a, this is how we declare an array, bit r, and equal an empty array. Its own size is 0. So for I equals 0, I less than 8, because from 0 to 7 or less than 8 means 8 values. I plus plus, do done. Then on the inside I need to fill it with zeros at first. Originally it will all be 0. So bit r $i is equal to 0, meaning from index 0 up to index 7 it will be all 0, and it will have 8 values, 8 zeros inserted on the inside, 8 blocks. Alright, so then now I need to also declare another variable, which we will call it position, and it will start at 0, because we need to loop through 8 times while decrementing the decimal number given by the user in order to fill up 8 bits. Of course, we're gonna only change the bits that have flipped from 0 to 1. So while at first $num and dollar, we're gonna open 2 parentheses, okay, so that everything on the inside will be measured or evaluated mathematically, while $num is greater than 0, and $position, okay, $position, we can write it in this way, is less than 8, meaning as we go and increment through the position, it needs to always be less than 8, because once it's over 8, we've gone above the range dedicated to code these numbers. Do, and we're gonna close it with done. Now, on the inside, what we're gonna do is open an if statement. If $num, and by the way, pay attention to the spaces over here, otherwise some, like for instance, if we don't give a space between if and these 2 brackets, you see it's no longer highlighted, it will give us an error. So if $num is greater than or equal to 128, then what I need to do is bit r or bit array, let's tab it over here. So bit array of 0 is equal to 1. Now, why bit array of 0? Because again, if you remember what we mentioned, that the lowest weight are on the right, okay, and the highest weights, which are like 128, 64, 32 going down, are on the left. So basically the numbers, because the array fills up from left to right, so the largest weight is sitting on the left, then it decreases gradually from 128 to 64, which is 2 to power 6 by the way, then to 32, 2 to power 5, okay, to the right as we go to the right. So the first element has the highest weight. So if num is greater than or equal to 128, meaning that we can deduct 128 from the given number which was provided by the user. So bit array 0 equal 1, and we need to deduct 128 from the number provided. So to do that, num minus equal 128. Then elif or else if, the same thing I need to do is $num if it's greater than or equal to 64, then automatically the bit array at 1 this time, because 64 is the second position from the left, okay? So bit array 1, and here, by the way, the indexes are from left to right concerning an array, that's why, okay? Now when we've given and we've expressed or explained the example of how to convert on the PowerPoint, it was 0, 1, 2, 3, 4 from right to left, but when it comes to an array it is inverted, right? So bit array 1, which corresponds to the weight 64, is equal to 1, and then we need to deduct whatever number is left, okay? We need to deduct from it 64. The same thing elif $num greater than or equal to 32, then what we need to do is, of course, bit array 2 is equal to 1, and then num minus equal 32, and so on and so forth. Of course, we're gonna continue. Elif $num is greater than or equal to 16, right? After 32 you have 16. Then bit array 3 is equal to 1, num we take from it 16, we close it. Elif $num is greater than or equal to 8. In such case, okay, then bit array 4 is equal to 1, num minus equal 4. You see the sequence? I'm sorry, num minus equal 8, okay, because we are at the weight of 8. Elif or else if $num greater than equal to 4, in such case we need to deduct 4 bit array 5, in such case the position, and we take from num 4. Elif $num greater than equal to 2, then bit array of 6 is equal to 1, and num minus equal 2 in such case. Finally elif, that's the last case, $num greater than equal to 1, that's the last number. Then bit array of 7 is equal to 1, and num minus equal 1. Finally, we close the if statement by phi. One final thing, we need to increment the position and break out of the while loop. Position plus plus, then we close the loop, the while loop. After that, display the value, the outcome that we've done, echo. At first I'm creating a new empty line, and echo binary code of input, because as you know the num value has been changing, has been decrementing inside the while loop. That's why I'm using the input value where we stored the original value of the number given by the user, is and $, and this is how I display all the elements of the bit array with one line. So dollar, I open curly braces, bit r, open two brackets, and ampersand. This will give me the entire array immediately. Now let's save and try to run. And by the way, before I forget, you see here, these will cause us problems. Okay, we need to like space out between the numbers within the if statement and the elifs and these two square brackets. Now if I run the script, let's try to run it. So bash intro, enter a number, let's start with 3. You see 3 will give us this value, which is correct, because here the weight of the first 2 bits from the right are respectively 2 to power 0 and 2 to power 1, which is 2 to power 0 is 1 and 2 to power 1 is 2, right? 2 plus 1 gives us 3. Let's give it another run. So let's say 16. 16 is 8 plus 4 plus, okay, or no, you have actually 2 to power 4 is 16. Let's check it. 2 to power 0, 2 to power 1, 2 to power 2, 2 to power 3, 2 to power 4. Yeah, that's 16. All right. Now I'll give you another example. Bash intro, let's try 125, and you can make sure it's correct, because if you add up all the weights from left to right, it will give you 125. Another thing, let's reverse the process, meaning that let's loop through the array that we've gotten and try to recover the original decimal value given by the user. In order to do that, meaning here we're trying to convert back from binary to decimal. So I will declare an initial value, decimal 0, then I would go inside a for loop for I equals 0, I less than 8, I plus plus, do done. And let's work inside the for loop to see how to recover that number. So here is what we're gonna do. So decimal, we're gonna, each time I go inside the for loop, I need to add this equation, if you will, which is, as you see here, how have we actually, or how can we actually come up with the decimal number? You multiply the bit value at each position with the weight, and you add up all the outcomes. So here it is 0 times 2 to power 7, which gives us 107, but since you have 0 multiplied by it, it will give you 0, plus 2 to power 6, actually plus 1 times 2 to power 6, which gives us 64, so it will be 64, plus 1 times 2 to power 5, which is 32. So 64 plus 32 plus 16, all the way down. This is how you get the decimal number back. So I will open the array, curly braces, okay, bit r, and then now here pay attention to the index. The index, okay, it needs to start, since we are starting from the lower weight, it will need to start from right to left, because 2 to power 0 sits on the right, not on the left. So $bit array here needs to begin from the right, which is position 7 based on the constellation of the array itself. Okay, so it will be the 7th position concerning the array, because the array works from left to right, unlike, you know, the binary add up that we've been doing. So it will be 7 minus $I to get to the one to the right, to the first element to the right, times, and I will open parentheses, 2 to power, this is how I give the power, I'm sorry, yeah, an important thing over here, you see, okay, that should take place outside of the curly braces of the array. So times, and I open two parentheses, 2 to power, this is how we get the power, it is 2 stars, and power what? 2 to power I, correct? So 2 to power $I. And then finally echo the original recovered decimal is and dollar decimal. All right, so let's see if numbers will add up. I will clear the screen, bash intro 125, and you see, okay, it gave us the binary code of 125. Then using that formula, that loop, it recovered 125, which affirms to us that our work is correct. Okay, I'll create a little space here, another trial to it. So let's try 64. 64 will give you, yeah, 1 bit turned on, which is 2 to the power 6. The second one from the left, and that's 64 over here. So that's correct.